Okay, so now, finally, we're going to talk about proportions. Proportions are going to play a role in many common problem types um, that are useful for us. Now, the word proportion simply means a statement that two ratios are equal. And this may seem very trivial, um, but you're going to see as we do lots of different examples that the idea of a proportion can capture a lot of different problem types. And so to know how to interpret a problem as a proportion, if it's appropriate, to be able to set up that proportion in the way that we're going to see right now, and to be able to solve the proportion um, is going to be very helpful. Now, in the coming examples that we're going to do in a few moments, you'll be able to see problems that can be solved as proportions, and we're going to be doing that right now. But before that, I want to show you this general solution technique for proportions. And it goes like this. Now, we know that a proportion is the statement that two ratios are equal, and we know that ratios are fractions. So this rule is going to make sense. If I have this fraction, a divided by b is equal to this fraction, c divided by d. By the way, if you're worried about the fact that this has letters in it, I want you to bear with me, because you will see as we work out some numerical examples that it's not going to be too difficult. So if a over b equals c over d, then AD is equal to BC. In other words, AD is equal to BC. So I'm going to do a simple example here. Example. Let's say that 3 over 2 equals to some number that we don't know but we want to know, divided by 5. So if this was the setup from a proportion problem, we could use this setup and we could use this fact to solve this proportion for the x. What would we do? Well, if a over b equals c over d, then AD, so 3 times 5, would equal 2 times x, which we're going to write as 2x. Okay? Let me get rid of this times sign. We'll replace it with we'll just put the 3 and 5 in parentheses, put them next to each other. That's going to indicate that we're multiplying. Well, we can see from here 3 times 5 is 15. So this is going to imply that 15 is equal to 2x. And then here, to isolate the x, I'm going to divide both sides by 2. Divide by 2. Divide by 2. And I get x is equal to 15 halves. And for this example, I'm going to leave it there. But in the future examples to come, I'm going to show you how you can convert that from an improper fraction, as it is here, or as a mixed number, or as a decimal expansion, whatever will be appropriate to the given proportion problem that we're solving at that future time. But anyway, now let me just highlight something very important here. Because this rule is going to be so valuable, I recommend that you put this in your notebook with a box and that you commit this to memory. And if it helps, say it out loud. If a over b equals c over d, then AD equals BC. And remember how it looks also on the paper. The numerator of the fraction on the left times the denominator of the fraction on the right is equal to the numerator of the fraction of the right times the denominator of the fraction on the left. Now, the way I said it there, it may seem more complicated, but you can see visually A times D is equal to B times C. Well, it's equal to C times B. Yeah. And, but there you have it. And so this is the beginning of what will be a very common and useful idea. And this technique will be absolutely crucial, as you will soon see. Thank you.